This chapter, our fourth chapter, is on dispersion. Let's give you an example here of a situation. Let's say we have rates of return on two groups of stocks. Group 1 are two utility stocks. Now this group has stock 1 has an 8% return, stock 2 has a 6% return. Then we have a second group of stocks which are retail stocks. Stock 1 has an 18% return on investment and stock 2 has a negative 4% return on investment. Pause the video here and think and compute the mean rate of return on each of these investments. As you may have already surmised, the mean rate of return is 7% for each one. And yet we would not say that these two groups of stocks are performing similarly. So therefore, we need to realize that not only do we need a measure of central tendency or an average, but we also need a measure of dispersion. Dispersion is the amount of variability in a data set. Okay. An antonym might be uniformity or consistency. The more dispersion there is, the less consistent it is. But we need to be able to describe how much variability. The easiest measure of dispersion is the range. That's simply the distance between the highest and lowest value in a data set. So for example, in group 1, utilities, well, the difference between the highest and lowest is 2%. So we could say group 1 had a mean of 7% and a range of 2%. Group 2 had a range of 22%. So by looking at those ranges, we could tell there's a big difference between these two groups of stocks as far as the variability in their performance. Variability is very important in risk because of rates of return. Risk, there's more risk in group 2 stocks than there are in group 1 because there's much more variability. Now the range is a great measure of dispersion. It's very simple. It's easy to understand. However, it only uses two values in a data set. Therefore, if the data set is quite large, for example, if there's a large number of values in a data set, there's 1,000 values in a data set, you'd be ignoring 998 of them. So we need another measure of dispersion. And what comes in next is something known as the average deviation. A deviation is the distance between a value and the mean. How far a value is away from the mean. It's algebraically defined by taking x minus the mean. That gives you the difference. Let's take a look. Back in chapter 3, we had 5 scores. A student had 5 scores on exams. It had a mean of 81. So as you can imagine, with the average deviation, what we're going to do is figure out, on the average, how far is each value away from the mean. So if we take 90 minus 81, we get 9. 83 minus 81, we get 2. 85 minus 81, 4. Negative 9, negative 6. As you can imagine, with the average deviation, we're going to add up these values and divide by the number of items. Pause the video here and see if you see a potential problem. As you may have noticed, if you add up all of the values, you're going to get 0. And that's the mathematical definition of the mean. When we have negative 15 and a positive 15. So what we need to do, we need to figure. We don't really care that these numbers are positive or negative. We just care what their value is. So the way that we're going to get around that is by finding the absolute value. That's where you ignore the positive and negative numbers. So to find the average deviation, we're going to take each of the deviations and ignore the positive and negative values. Add them together and divide by the number of items. In this case, the average deviation is 5.8. And the way you interpret that is that you say, on the average, each value is about 5.8 away from the mean.